Okay, hello everyone again. You need to see me again. I'm sorry for that. It's the first talk after lunch, so I hope you don't get sleep. Today I want to talk about what we call the technical vision for VAST, or the VAST platform, previously VA, Smalltalk. I mean, for that Visual Age for Smalltalk, we have still some customers calling it Visual Age. So the agenda is that as part of discussing the technical vision for VAST, we will first start with explaining our general approach and philosophy that we use internally to evaluate which features and which changes we make to the product. We will then talk about the technical foundational areas of VAST and how they are a frame of reference that can help us define the features and changes that we have been doing over the last decades in the product and what we're going to do next. We will provide some examples of these, what we call foundational features. And finally, I will show how this technical vision that we have help craft not only the next release of VAST, but also the future releases and a more long-term vision. So that's more or less what I would like to present. So, to start, what general approach and philosophy that I described before drives our decision? What is what drives our decision at this situation? So, in short, at this situation, we try to provide software support and development that balance innovation with stability, sustainability, and user experience, while minimizing risk to both software itself and the team supporting that software. And this is what we have been actually doing since the beginning of this transition. It's just that we never had the time to actually talk about this. And this general approach that we do at these transitions as a whole, obviously VAST is not an exception, so we follow these principles, these guidelines. So again, keeping in mind that we try to do a balanced approach on how we create new features and how we continue to progress the product, the VAST platform, the question that first I would like to answer is, what are the key technical foundational areas of the product that we focus when we develop these new features or new changes? So with that, I would give a quick list of these foundational areas or areas of focus that I was talking about. So the first one is to have a very fast and solid multi-platform language runtime. We will see examples of this later, but this is very important because VAST is used at the very bottom of the user stack or customer stack. They build on top of VAST, so VAST needs to be rock solid and fast because it's at the bottom of their stack. We want to focus on supporting multiple architectures, so we would like to have native thick client applications as well as web and hybrid applications, as I will do an example later. The other foundational area is about packaging your application and how you deploy that, and ideally it should be some kind of cloud friendly these days, so we are focusing on that area as well. We need a really rich set of core libraries. So as you know, with Smalltalk, it's not just the language. It's the base language, you have all the tooling, the IDE, there are lot of libraries in Smalltalk per se. And we want to be really solid when it comes to communication and networking. This is something that has been becoming more and more important over the years, and in our opinion, it will continue to be like this. Databases is still critical for customers. Everybody needs some kind of persistency. Security, this is one of the top priorities at this point at VAST. And again, a little bit of don't lose focus on one of the things that make Smalltalk great, which is a nice productive development experience, right? So those were the main areas where we like to focus when we develop the VAST platform. So what I would like to show now is what we did in the past, I would say the last 10 years, the last 15 years, that align to this foundational area. Because at the end of the day, what I want to show is that we don't do things randomly. It's not that we woke up and say, oh, okay, today I want to implement this. No, we have a vision. So for those that haven't been following what we did in VAST for the last decade, I think it's a nice summary of what we did. And later we will see what we're doing next. But now we'll start with the past. So I will try to go quickly on each foundational area that I talked before. So the first one in the language runtime, one of the most important things we did is we completely rewrote the VAST virtual machine. So we stopped using IBM machine. We rewrote it using modern technologies and standards. It's actually built on top of the latest LLVM, and it's designed for portability, as I will show in the next bullet point. For example, we added 64-bit support. This was a couple of years ago, which was possible because of the new virtual machine. And the same goes, for example, for ARM processor. This is newer. This is maybe 2 years or 3 years ago. We added ARM native support for Windows and Linux. We made FFI much faster. We did a lot of performance improvements using CMD instructions, which is kind of a set of CPU instructions to process in the same instruction. You can process multiple sets of data. That's more or less what it is. I'm not an expert in virtual machine, but that's what I understand. And also we improve we can handle now Smalltalk images of gigabytes of size, which was not possible before. So now we have some customers with really huge image files. And finally, the last thing we need to do in this language runtime kind of area is to always keep up to date with all the latest Windows and Linux releases. That's not always easy, so we always need to do that. Now, regarding the multi-architecture foundational area, first starting with let's say the most classic one is the native, the thick client native application. So we've been doing a lot of things on this area. We added full high DPI support. So now font scales very nicely. You can even have multi-monitor with different DPA scaling factors. We have direct write support for fonts and some new native widgets. So for example, for Windows, we added the new table widget, things like that. So we have some set of new native widgets. So that's more or less in the native thick client area. On the website, we are always upgrading to the latest C-side. So we try to be current with C-side and Wiz. And we added Unicode support to C-side. for BAST. So now in the latest version of BAST, C-side can be Unicode ready. You can render Unicode, you can input Unicode. So we did that. And finally, regarding the hybrid approach, the most significant thing we did is to give support to WaveView 2. For those that don't know, this is a feature from Microsoft that is coupled with the Edge browser, and this gives the ability to embed the Edge browser inside a Windows native application. So using this technology, some of our customers are building what is called hybrid applications, where they kind of do parts natively and parts web. They compose in the same native application. Okay, the next foundational area is about packaging and deployment and cloud. Here, one of the things we did, I think it was last year, we improved the packaging, the performance of the packager. Mostly if you have a big image, if you need to package a large vast runtime, it's significantly faster now. We added a little tool, it's called automatic build system, which allows you to make the packagement of your runtime image in a non-interactive way, so you can script it. Final runtime, the ICX, which is the Smalltalk image for the end user, make that easier from a script. And then we try to be, we have a lot of customers using containers like Docker, Kubernetes. So we try to be friendly for this kind of cloud deployment. By friendly, I mean that, for example, we have a very small runtime. The size of the virtual machine binaries is quite small. Images, since we use the packager that reduces the final image, it gets very small. So there are a couple of, so we have also minimal dependencies. So for example, on Linux, we almost depend on libc, and that's it. We have minimal dependencies on the virtual machine as well. We support multiple Linux flavors, so it makes it easy to deploy in Docker, and we have multiple customers already doing so. Regarding the core libraries, here we did quite a little bit over the last years. We added Unicode support. This is one of the most important features we did. We created a nice Unicode, we call it Unicode support library. It's kind of the low-level library that then gives support so that we can integrate Unicode at the different layers. But this is kind of the low-level library that has Unicode string, graphene, Unicode Scala, etc., etc. We added asynchronous programming features, so we added support for futures, promises, streams, so got this idea from Dart. And again, we have customers already using this extensively to improve performance. With OS plugin, so if you need to fork OS processes from BAST, it's a very nice cross-platform tool that we did. We added a lot of compression libraries like LC4, Broadly, C standards, C, etc. We added regex support, much better configurable error handling. We improved the stack dumping. We know BAST has this, I love it. You can serialize the stack when there's an exception, and then you can debug it later in another image. So we have improving that. We have also remote debugging, which is similar, but it goes via TCP between the runtime image and the development image, so you can even change code and resume. So that's pretty awesome. So we keep improving that. We added time zone support for our date and time interfaces. We added logging framework and some more. This is just the latest development that we've been doing in the core library. Going to the communications, networking, this is, as I said, together with security, I would say is one of the most important areas. It has been changing every year. So a couple of years ago, I would say 10 years ago, we added IPv6 support. That was a major effort. We added a lot of text serializers like JSON, CSV, Stone. We even added Unicode support to Stone, which is the Smalltalk JSON serializer. We improved the XML parser. We added support for LDAP and secure LDAP, LDAP-S. IMAP, we had IMAP as MTP. We improved a lot the HTTP client because a lot of people are using the HTTP client to call REST APIs or whatever. So the HTTP client is being used a lot these days. So we need to improve it. We added SSL and 64-bit support to IBM MQ series. We added a new FTP, FTPS. We added MQTT, which is this was also a nice tool. We have customers already using MQTT. Regarding database, this is more like, let's say, less innovative. It's less. It's more like what our customers need to do. They need to persist data. But we cannot just look to another side and ignore it. We still need to continue improving it. So we expanded our list of relational databases. So we added support for Postgres recently. Soonish we are giving support to SQL Server. We keep improving Glorp, which now over the years we have been making extensions and fixing bugs in Glorp. Glorp, for those that don't know, is our object relational mapper. And finally, we added Unicode support also at all the database layers. We added at the driver level, at the Glorp level. So as you can notice, not only we added Unicode support at either low-level library, but we also have been integrating Unicode in a lot of different modules of BAS. Regarding security, as I said, this is one of the top priorities these days. And the most important single thing we did is that we have a complete object-oriented wrapper of OpenSSL. It's a very complete, very, as I said, object-oriented. It's very nicely done. And that enables everything I will just mention very quickly. That allows us to have SSL or TLS modules in the different places in VAST, secure memory arenas, secure R&G. We have multiple choices for symmetric and asymmetric ciphers. Key derivation options, we have multiple method authentication options, we have plenty as well. It's basically everything that OpenSSL supports, we can support it in VAST. Okay, we are getting to the end, so don't worry, we're getting there. So then from the developer productivity and development tool, what the biggest thing we did, maybe it was maybe 8-7 years ago, we did a state-of-the-art code assist. If you use other Smalltalks and then you use VAST, you will notice that the code assist is very good. It's well done. It has a type analysis. It has code completion, live refactoring, like renaming and things like that. There's some linter, so you have like underline when something is wrong, all those kind of things. And we upgraded to use the latest Scintilla editor on Windows. So now we used to be stuck in an old version, so now we're using the very latest version of Scintilla editor even with GPU acceleration, which is nice. It's fast. And then again, we continue improving Unicode integration at the different layers of the IDE. So we did it in workspaces now. Workspaces are fully Unicode aware. Inspectors, debuggers, we will continue. So it's integrating Unicode is an ongoing effort that because there is unlimited amount of modules that would benefit from being Unicode aware. And finally, we improved some browsers like the three-way diff, the profiler, the SUnit runner, and a couple of typical browsers that we have been improving over the recent years. And finally, we added support for Tunnel, which is kind of a Git-friendly file format. Probably you're aware of this. So why did I tell you all about this? Why I spent 20 minutes of this? And I think that in summary, all of these features and foundational areas that I have been they are not randomly selected. This is what I was saying earlier. We are not randomly selecting features. We are not randomly selecting changes. We have a vision that shapes what we did in the past, and as you will see now, what we are going to do next. So let's see what we are going to do now. So what we are doing for this release. So we will, it's just one very quick slide about what we are going to do in the next release that will be released in a couple of months in Q1 of 2025. Sorry. So first is that we have some virtual machine improvements. As always, there's some virtual machine improvements. We migrated to the latest LLVM 19, I think it was. We improved the weak queue size, and so we resized the weak queue. A lot of Unicode library enhancements in the hash of Unicode string and string. We also updated to the latest Unicode version, so now we support version 16 of Unicode. We finished the integration of Unicode with CSI, as I mentioned earlier. Better Unicode support in the development tools, as in the inspector, debuggers, workspaces. They are now all in the upcoming release. Unicode support for XML. We are still trying to do this one for this release. We might not get in time, but still trying. Multi-monitor and high DPI improvement. This one is done. We now Rust now opens Windows in the correct monitor, even if you have multiple monitors, even with different scaling factors, it will work fine. We updated to the very latest OpenSSL, which is critical. It's always nice to update to the latest. And as I said, we are trying to add support for SQL Server, as we have some customers that they were already using through ODBC, but we try to make sure that everything works as expected. Table widget integration with Windows Builder Pro. This is again for the free client user. And finally, we continue an ongoing effort that takes years, but is the GTK support at the beginning for Linux. So we started doing this, and we continue doing this. So even if it won't be ready on this release, I just wanted to mention that we're still working on that. Okay, and that was what was coming in this release, but the technical vision, or what I wanted to try to explain in this talk, is that this shapes not only what we have been doing, but also what we are planning to do. So this is not a set in stone list, but this that I will mention now are some of the things that we are planning to do in the upcoming releases. So one thing that we want to really invest is in CSI. There's some enhancement that we have in mind. Now with Johan starting working with us next year, we'll probably improve CSI even further. One of the things we wanted to explore, and that Johan mentioned this a little bit in his talk, is we have some customers wanting to do stateless CSI. So we would like to try to see if we can accommodate CSI so that if we have customers wanting to do stateless CSI, there's a way, an easier way to do it. So we will be working on that. Swagger and Open API, it's important if you're doing REST. GTK continues, as I mentioned, more Windows native widgets. Continue improving if there are problems, more problems with IDPI and multi-monitor support. We want to fix them all. More Unicode integrations. For example, we are still missing XML. We are missing web services, for example. So there's still a few areas there where we need to add Unicode support. OAuth 2 and OpenID. This is very important. It has been asked multiple times at this point. So we will try to implement something. The same goes for WebSocket. Ideally, support for non-blocking sockets. So those are kind of some of the networking pending topics. We also want to build a software vulnerability scanner. Again, because security is one of the top priorities. We would like to at least understand what it would be to implement a security vulnerability scanner for BAST, for both our internal code as well as customer code, so that they could run their code and look for potential security vulnerability. We are thinking things like signing and encrypting the Smalltalk images, the ICX, or even ICs. Maybe in a new deployment unit, we're just brainstorming this idea right now. More secure and performant Envy. You will see a talk from Seth about that. And finally, well, the virtual machine is always on all the time. There are improvements on the virtual machine. There are plenty of things that we could do. I would like to have a headless packaging right now. If you can script it, you still need a headful image. So I want to be completely headless and be CI friendly. And finally, some AI investment and explorations that we are doing. We have already started to heavily invest on AI. We are actually starting the first project this week or this month. We have a couple of approaches. What I can say is that our idea for AI is basically help with what we call developer education, improving customer satisfaction, and assist, and this is very important, assist with system currency. So we want to assist our customers to be up to date with BAST and their system. They don't want to leave them behind because the people is not there anymore. So we're trying to see how AI can help. I don't want to say legacy systems because some people think about that negatively, but we're trying to think how can improve all of those areas. It's really exciting time for presentations and the community as whole. When it comes to AI, we will have a panel. I think it's Friday, tomorrow. We'll have a panel to discuss Smalltalk and AI. That's it. That's all I have to mention. Thank you. Okay, any question? Yeah.
Thank you. What is live refactoring? What is live refactoring?
We have a few inline renames, for example, where you can, in the text editor, you can select the variable and rename it inline, and it will show and rename it in the editor. On the editor itself. Okay. And I think there are a few more like declared temp bars, and there are a few like those.
Okay.
Right.
Hello. You mentioned you had a feature that enabled live debugging of a runtime system,
Yes.
and you said that the method could be changed through the debugger, and then that actually saves to the ITX and the runtime image, or does it not?
It's so that's a good question. The way it works is so you have a host or development image. You package your runtime image, and when you're packaging that runtime image, you need to tell an IP. Okay, so once this runtime headless image writes an exception, you can connect via TCP to the IP that you set.
Through the
and then,
development.
Yeah,
Through the
to
development.
the development image. So you will get the debugger in the development image, and if you change the method, as far as I understand, it will compile the method, send it over the wire, and apply it on the runtime image. That's why you can change and resume, and it will work. As far as I understand, maybe it says no, but it doesn't save the image, as far as I understand.
So if I restart the runtime image, then
exactly,
I would not.
exactly. I think it's like that. I would need to double check, but for sure it kind of compiles and sends the bytecodes over, replace it in the runtime image, and you can continue. But it only works for headless images, which I think is the case of in OpenPath.
Yes. Thank you.
So, thank you.